the last few topics before the midterm on Monday. And later today, I'll be posting a sample. I was looking at the sample I've used in previous courses, and it covered a slightly different set of topics. So I don't think that it's entirely fair to ask you about things I haven't talked about yet. So, yeah.
Question about the midterm, is it going to be similar to the quizzes? Or
It'll be, yeah. You'll see a little bit more with the sample. It'll be more like short answer rather than multiple choice as the quizzes are. So, but it will cover some of the same material, but it'll also cover things in the reading and things that I've talked about here, but not as a, how should I say, it's like if what I've asked about on the quiz is only a partial coverage of the topics. So. Okay, so today I want to revisit this super thing because it's important to understand this next topic, which has to do with subclassing, inheritance, subclassing, class hierarchies, and what it brings up are how to organize projects and other issues such as overriding methods, which is similar to but different from overloading. So understanding the difference between overloading and overriding is one thing you do need to understand. And then class hierarchies, which today I'm going to touch on, but tomorrow we'll go into a little bit more detail about how all this works, as well as the overriding business. So today is kind of a little more abstract in what I'm going to talk about, and tomorrow I'll be giving more examples about it. Okay, with super, there are two things to deal with as far as super goes. So the first thing to remember is that the super refers to the immediate superclass of the class that you're in. Okay, there are two references like this. The first one is this, which we've seen, as I said, which is a badly named one, but once you accept that, this refers to the particular instance that you're in. And when you're referring to instance variables and instance methods within the class, this is always assumed. That is, if you were to look at the byte codes that actually get generated, they put the this in. So the thing to remember about that, and that's important when you're trying to figure out how to write code that does stuff. When you're invoking a method, an instance method, it is always object.method. Object.method, that's the thing to remember. And coming from procedural languages, like scripting languages, you may be used to just calling a function. And it may look like that when you're inside of a class because you're just referring to the method by its name. The thing to understand is that even in that case, it is always this dot method when you're referring to an instance method. The other thing to remember is that when you're invoking a class method, it is the name of the class dot method. Okay, so methods, well, what you should take away from this is that methods are always invoked on a particular thing. And that thing is either an object if it's an instance method, or a class if it's a class method. That's the this. Now super is the other built-in reference to the instance of the superclass. So it's a much better named thing than this, because super is, I mean, as long as you're not thinking like Superman or something like that, it's refers to the instance of the superclass that's kind of embedded in the whole thing. So When it comes to constructors, the first call to a constructor is always going to be a super or a this. And when we talk about overloading constructors, then this will kind of come into it. So, but for right now, the thing to remember is the first call in a constructor is going to be super. So that's the first level. Just understand, we'll say more about that later. Constructors aren't inherited, and this is something important to understand. Methods are inherited. Instance variables are inherited, even though they will typically not be directly accessible. And in the context of constructors, the super refers to the constructor of the parent class. You can also use it to, if you are overriding a method, you can use it to refer to the implementation in the superclass. We haven't seen an example of that. We'll see an example of that tomorrow. Okay, they say that the first line of a child's constructor, they say it should use actually with the exception of overloaded constructors, it always uses a super reference, and you can be explicit about that or implicit. If you don't put super in, Java will put one in for you, and it may not be the one that works. We saw an example of that yesterday. The reason it's important to understand that is because it's a really confusing error message when you see that. If you are inheriting a class that has a constructor that requires an argument, and you subclass that, when you first start writing it, you're getting this really confusing message because it says there's a call to the constructor, and it's expecting an int say, and you're just giving it nothing. And you say, well, wait a minute, I haven't even written a constructor. So as I talked about yesterday, if you don't write a constructor, Java will put one in for you with 0 arguments. And if you have a constructor and you don't put in a super, Java will put one in for you with 0 arguments. The problem there is if the superclass constructor requires an argument, then a call to that with no arguments is going to be a failure and lead to the infamous red squiggly. Now, the way that objects are constructed, and this is where I want to, hopefully you can still see this. Well, we can see it, so that's, all right. So what happens is that when you instantiate an object, it walks up through the class hierarchy of constructors first, and then walks back down to execute the code in each succeeding constructor. And we can show that with this example from the book, which I've modified a little bit. So what they call book 2 just has one instance variable called num pages, and it just has a setter and a getter. I think the book had get pages rather than get num pages, but that's normally your setter and getter should match roughly what the name of the instance variable is, and has a single argument in its constructor. So this, and now this super is something that I put in just to make that explicit, because whether it's there or not, whether it's written there or not, it's going to be there. Dictionary was a subclass of that. And again, how do you subclass? You say extends. So dictionary 2 extends book 2. which means dictionary to is a book. And its constructor has two arguments, one, the number of pages and the number of definitions. Now here, you have no choice but to explicitly put in the super. Why? Because if you leave that out, then you get this weird error message that says, again, when you see this message now, you know what to do. And that's so much of coding is debugging rather than writing the code. And so one of the important skills to have is figuring out what to do when you get those error messages. And there are two kinds of error messages in Java: compile errors, which is the red squiggly we get here, and runtime errors, which is when the program is syntactically correct, but is incorrect in its logic somewhere. Those are much more difficult to unravel. And the reason why a compiled language or a semi-compiled language like Java is preferable when you're writing large projects is because you want all of these errors to be picked up by the compiler. When you have a language that doesn't do that, like Python or JavaScript, and you're writing a large program, then what will happen if you do any of that is that it will run for a long time and then all of a sudden hit some code that's syntactically incorrect. And when it hits that, it will all of a sudden bomb out. So I have literally know about situations where a program is run like an hour and then bombed out because of a syntax error in code that wasn't hit until a long time into the program. So for large projects, a compiled program, a compiled language like Java is preferable. In other words, you don't want to run this program if you have an error like this going. Okay, so the skill to be acquired, therefore, is to try to understand what the heck this error message is about. Some error messages are good and descriptive. Some are really bad. Now, in this, it's like Java's doing the best it can with what it sees, except it's confusing. So this is one of the things where you need to understand. It says, constructor book 2 and class book 2 cannot be applied to the given types. Required int found no arguments. Reason, actual and formal argument lists differ in length. Now that, once you know what the heck is going on, that should speak to you. But until you know what's going on, it's like confusing. Okay, so what's the problem? The problem is that Java has put in a super constructor with 0 arguments because you haven't written one. That's the problem. So when you get this message, you should now know what to do. That is, put in the constructor with the right arguments. Now, notice that the subclass, the constructor, has 2 arguments, but the superclass only has 1 argument in its constructor. There is no law that says the constructors have to have the same number of arguments. The rule is, though, that when you call the constructor, you have to give it the right number of arguments. So when you call this call to super is a call to this constructor. And this call to super, which I've put in explicitly, is a call to the superclass of book 2. Say, well, what is the superclass of book 2? It didn't extend anything. Well, it does. Every class that you write extends objects. So if I were to write extends object, again, no red squiggly, no complaints. Okay, so to save typing, because every class by itself, if it doesn't extend something else, will extend object. And this is a confusing name, but makes sense once you kind of wrap your head around it. object with a capital O is a class. So the class object is the granddaddy of all classes. Every class is at some point a descendant of the object class. Now, so just to show you how this works, let's trace through. In case here we're instantiating a dictionary 2. We're giving it 2 integers, which is fine. And so let's step into this. And we see that we went into dictionary 2, and the first executable statement is the call to super. So let's step into that. The first executable call in book 2 is a call to super. And when we step into that, we can actually see there it is in object. Now the constructor and object doesn't do anything, but it's there. Okay, now then when we step out, so that when you instantiate an object, it first walks up all the way to object in the class hierarchy, always. And then it steps back down, executing the code in each of the constructors as it goes back down. So object is just passed back to book 2, and then notice that it's moved on to the next piece of code in the constructor. And if there were more code in that, then they would execute that. And as we keep stepping over, then when it's finished with that, it bounces back to the constructor of the subclass and then executes whatever code is in that. And then finally, when it's finished with that, we can now step out, and now we have our object. Okay, so now since we're kind of here as well, let's look at this. Here we are invoking the get num pages. Okay, what is Webster? Webster is a dictionary 2. If we look at dictionary 2, it does not have the method called get num pages. So what does the virtual machine do? Well, the virtual machine is going to say, all right, you're a dictionary 2. Let's look in dictionary 2 for get num pages. It's not there. All right, then what does it do? It looks in the superclass. Well, I didn't find it here. So it's got to be in the superclass somewhere, maybe. Okay, here it happens to be in the superclass. So, and we can actually see that by stepping into here. So when I invoke get num pages on Webster, which is a dictionary 2, it goes to get num pages in book 2 because that's where it finds it. Okay, so that's okay. So hopefully, does that clear things up a little bit? Now, just to kind of put a little bit of point on it. Let's say that we didn't put that super in explicitly. So what would happen then? Well, pretty much the same thing. So again, we're instantiating one of these Webster guys. Okay, we call this super here. We go into that. Now notice that it goes, because there's the call to super isn't in the code, but okay, we're here trying to do this, but when we step into that, lo and behold, it goes to the super class in object as it did before. In other words, it invoked the super that Java had put in. Okay, so hopefully that, let's revert that. Hopefully that gives you a little bit more clarity on kind of what is going on here. And it's important to understand that because this inheritance idea is one of the big ones of object-oriented design. Now, it's a big idea and it can be overused. So, okay, so now overriding, we've already seen an example of that. Overriding is when you write a method which has the same name and signature as the one in the superclass, but you want to do something different from that. We've done that a number of times with the toString method. The toString method is defined in the object class. So if you don't override the toString method and you try to print an object, then what you'll see is the name, basically the name of the class and a bunch of gobbledygook, right? You've seen that, right? You have? No? Yes? You should have. If you haven't, then yeah. Well, okay, what is that? That's the toString in the object class. So what happens when you do a print line of an object, what that does is it invokes the toString method of that object. Every object has a toString because it's defined in that object's granddaddy class. So what it does is it goes looking for that toString. And if it doesn't find it in your class, it looks for it in the superclass. And if it doesn't find it there, it walks all the way up to object. And it has to find it in object because it's defined there. And if it doesn't find it, it invokes the object one. But if you have overridden it, as you have for the playing card, for the card deck, for all the other ones, then when it goes to print, it goes to the toString and then says, okay, here's the toString, I'll invoke this one. Okay, so that's overriding. And the difference between overriding and overloading is that overloading is a method of the same name, but a different signature. Again, overloading, we can have as many methods as we want with the same name, but different signatures. Overriding has the same name and the same signature. See, overriding basically lets you define a similar operation in different ways for different object types. So again, for the toString, that's what we've done. If I'm a playing card, my toString just wants to print the suit and the value. If I'm a card deck, then at least according to the specification that I imposed on you, the toString is supposed to print out the order of all the cards that I have in that array. And then for the poker hands that I'm asking you to write, the toString for that is going to print out the ID and what cards are in it. Okay, so true and false, child class may define a method with the same name as parent, as a method in the parent. Absolutely. You can override the constructor of the parent class. Sure. Well, I mean, in fact, you have to. Now, there is a final modifier. Remember what final means? Final means final. So if you define final anywhere, then you can't subclass it. So if you define it, you can define a whole class to be final and you can't subclass it. String, for example, is defined to be final, which means I can't subclass string. Is that a good thing or not? It's a safe thing. It means that if you're using a string or something like, you can't muck with it. If you declare a method to be final, then you can't override it. Just like if you define a variable to be final, then you can set it once and then you can't set it again. It is considered poor design when a child class overrides a method from the pen. No, that's something that you want to do sometimes. child asks me to find a variable with the same name. You can, but it's not a good idea. So they say, okay, true can override the constructor of the parent class. Oh, there you go. Okay. What they mean is you can't have a constructor of the same name as the parent class. Okay, yes, you can, with the variable, same name, don't. Okay, so here's an example of a class hierarchy. And as you can see, it's a little bit more involved. And hopefully you can see how this can be very useful. Namely, that the base class of this is just sort of animal. And they've divided this into reptiles, birds, and mammals. Presumably dinosaurs are birds. Okay, so reptiles, birds, and mammals, subclass animal. And then within reptile, we have snakes and lizards. Within birds, we have parrot, presumably a bunch of others. And within mammals, we have horses, bats, and other types of things. So in a large application, you could envision maybe a few more categories here. So amoebas are technically animals, I think, as our protozoa. So would that be included? Reptiles, you know, is a T-Rex a reptile or is it a bird? You know, and likewise, there are a whole bunch of birds, a whole lot of mammals. And you might want, depending on your particular application, you may want to subclass those as well. In other words, you might want to break mammals up into primates and other types of things. But the point is now that if I instantiate a bat, then I can look at it as a bat and do the bat-like things to it. And I can do mammal-like things to it. And I can do things that are common to all animals. So what this allows you to do is to define behaviors and states, like instance variables, in a way which matches the level at which you're talking about it. So if I have and here's where this comes, remember we talked about array lists and how with an array list, I have to tell you what kind of thing I'm going to put in it. So if I have an array list and I only want to have bats in it, I can define that to be an array list. Okay, let's see if I can print with this. Array list. If I say array list bat, then I can put anything that's a bat in it. And if I've subclassed bat further into, you know, vampire bats and fruit bats and, you know, all the other different kinds of bats, I can put them in too because they are a bat. But I can't put a horse in. I can't even put a mammal in or an animal. I can only put bats in. But if I define this to be array list mammal, for example, then instead of a bat, then I can put a bat, a horse, or any other mammal class that I've defined in there. Or if I define it to be simply an array list with animal in it, then I can put any one of these things in. So it's the ISA. So if I have an instance of a horse instance is not a bat, but a horse is a mammal, so it could go into an array list that was declared with mammals. It is an animal, so I can put it into an array list that declared it would contain animals. So depending on how I want to group these things, I can have as broad or as narrow a range of possibilities as I want. Okay, some of this terminology is not, they say two children of the same parents are siblings, again, that sort of makes sense. So a horse and a bat are siblings, sounds kind of strange. In general, and this is kind of why, part of the why. When you have common features, you want to put those as high in the hierarchy as possible or reasonable. And that way you can ideally implement the same thing once and then have it be shared by everything. Just as we saw just in a very small way, the get num pages in book 2 was shared by going to be shared by all of its subclasses. Like the dictionary 2 did not have to define that because it was already defined in the superclass. So that's good design because you're implementing a particular feature once and only once. Because if you implement the same feature in multiple places, Murphy's law says they're going to get out of sync. So everything in all of the ancestors, going all the way back to object, is shared by things. And this is something important too, like when you, one of the things that frustrated me a bit with the object-oriented literature when it was coming out, and it was such a big thing, is that they were acting like there was kind of only one way to think of these. And there isn't. It depends, this is all very context dependent. It depends on what you're trying to do, the level of detail. So for example, in a particular application, this level of detail may be all I need. In other words, if I'm not representing things down to the specific type of animal that I'm dealing with, but I'm only interested in differences between these different categories, then this may be as far as I want to go. On the other hand, if I have an application which, let's say it's a searchable type of situation where I can bring up a picture of the animal and a description of all of its different features and things like that, then I probably want to go not only, I probably want to go even further down here to specifics of these in that context. Or if I'm only concerned about animals, vegetables, and minerals, I may be perfectly content with just saying something is an animal to distinguish it from a vegetable or a mineral. So the point is that there's no one class hierarchy that is the universal one, and that's important to remember. It's kind of up to you. So we talked about the object class. It's in the Java Lang package. Again, Java follows its own rules, or as the saying goes, eats its own dog food in this case. It allows you to put classes in the unnamed package, but discourages it. And in fact, every class in Java, the Java distribution, is in a name package. So all of the basic ones are in the java.lang package of the standard class library. Every class, they say direct, is a subclass of the object class. And again, it's a bit confusing, or it can be confusing if you're not sort of careful about what you're, because we have an object with a small o is an instance of a class. An object with a small o is an instance of a subclass of the class object with a big O. And to make things even more confusing, there's a class called class. And an instance, an object of the type class is also a subclass of the object class. But we won't talk, we're not going to deal with the class of the class. So you can forget what I just said. In addition to everything else that I said that you probably forget, but some of them I'll be asking you about, so you might want to reconsider some of the things you're forgetting. Okay, so we've talked about the toString and how we're always overriding it, and we have overridden it. We've seen examples of that. Okay, so this is something which is also which kind of comes up. There's a method in object called equals. And the way that it's implemented in the object class is that it returns true if, well, they say if the two references are aliases, meaning that they're both pointing to the same thing. We can override equals, and for example, string overrides equals. In string, equals is overridden to return true if it contains the same characters up to case. We've actually seen an example of that. At least I provided one. If we well, there's the equals ignore case, which is another method, which is not an object, because object doesn't know what a string is, but a string is specifically a set of characters, and so equals returns true only if the characters are an exact match. But in working with strings, sometimes you want to say, well, I want to consider them equal if they're even if the cases don't match. So that's a separate method that string adds called equals ignore case, and that only works on a string. Whereas equals can be applied to every single object, period. Why? Because it's defined in the object class. And we've seen an example of this, or at least I don't know if it was pointed out, but in the playing card class, at least as if you remember, this is an example of overriding it. In fact, notice it asked me to add the override tag. So the equals method requires an object of the other, and the signature is object, capital O, and it returns a Boolean. So for a playing card, what did I want equals to mean? If I had two playing cards, even if they were two different references, if they had the same suit and the same value, then they're the same card. Okay, now because the argument is an object, first of all, if I ask you, are you equal to null, that's always going to be false. And this just says, if you're not a playing card, then there's no way you can be equal to me. So in those cases, I can quickly return false. But if I don't do that, if I make it to here, then I can safely cast this object to a playing card. And I need to do that. Why? Because I want to see whether or not the other card suit is equal to this suit and the value is equal to this value. And if both of those hold, and even if they're different references, then I'm going to say that for my purposes, they're the same card. Okay, that's overriding equals. And equals is defined in the object class, as I said, so. And in this case, it was a more useful version, as with the string class. Okay, the final thing is our abstract classes. Now, what you say, well, what's going on with an abstract class? So we can define an abstract class, or a class to be abstract using the keyword abstract. Now this is it's a fairly descriptive. I would say it's not as descriptive as some things, but it's fairly abstract as opposed to concrete. So abstract is the opposite of concrete. A concrete class is one that I can instantiate. An abstract class is one that I can't instantiate. So you may be thinking, why would I want to define a class that I can't instantiate? Or maybe you're not thinking that. I don't know. Typically, and this relates to the concept of an interface. Sometimes we want to define, to make sure that every subclass has a certain method, but we don't want to specify exactly what that is. In that case, we can declare a method to be abstract, and that has basically the same syntax as we saw in interfaces. Remember, interfaces was like a contract. I said, with an interface, I have a method, and I just say you have to implement this method if you want to implement this interface. An abstract class is a similar kind of thing, in the sense that we can define an abstract method, meaning that we can simply say that you must have this method if you're a subclass of this class, but the way that you do it is going to be specific to that subclass. So if I'm in a situation where I want to define some but not all of the methods, then I can implement those methods that I want to be common to everything, and then declare the other ones to be abstract. And when I do that, I have to declare the class to be abstract. Now, I can simply declare a class to be abstract without having any abstract methods, although I can't think of a use case for that, but okay, so now if I want to instantiate one of these things, I must subclass it. And the subclass must override all of the abstract methods, or it too is going to be abstract. So I can subclass an abstract class and only implement some of the abstract methods, but then I say I still have to be abstract. Now, it doesn't work for static methods, and it obviously, is it clear why final wouldn't work here? Remember, a final. Exactly, yeah. In other words, I can't be overridden by a subclass. So if I declare something to be abstract but final, it's on the one hand, by declaring it to be abstract, I say you must override it, and by declaring it to be final, I say you can't override it. So it's like, it always reminds me of there was a role-playing game I was playing once where I had to get into this building, and there was a guard there, and you try to go in. He says, "I'm sorry, you can't get in. You need a pass." And I say, "Well, where do you get a pass?" And he says, "In there." So and it turned out you had to go around the back and break in, but that was okay. Okay, and that description of abstract may seem a little abstract, to coin a phrase, but we will make it concrete by showing an example. If not tomorrow, then next Tuesday. Now we can also apply inheritance, which is inheritance is not the best word for it, but basically we can have hierarchies of interfaces. In other words, I can have one interface which extends another interface. And what that means is that if I've added additional methods, then you have to implement all of those methods. And we're going to go into this in a little bit more detail as the course goes on. But one of the things to kind of understand is that an interface hierarchy has the opposite effect of a class hierarchy. So with a class hierarchy, as I subclass things, I gain functionality. In other words, as we've seen in the dictionary class, when it subclassed book, it gained functionality, gained all the functionality in the superclass. And that's a general principle. Whenever I subclass something, I get everything in the superclass. Interfaces kind of work in the opposite way. Remember, in an interface, it's like a contract. So if I have a sub interface, that means there are additional things I need to implement. So a sub interface adds work, whereas a class hierarchy makes work less. Some method, well, we have toString and equals we've seen. Clone we haven't talked about, but okay, what is an abstract class? It's a placeholder in a class hierarchy, gathering elements, common. This is sort of just the main thing to remember. It can't be instantiated, but it can be useful of gathering elements common to the derived classes. And that should be fairly abstract, but nevertheless, we're gonna look into some concrete things for that, and then finish chapter 9, and the midterm, as I said, that will be coming, will be through everything that we've covered through chapter 9. We have not talked about any of the Java FX stuff. You may be sort of reading about that. That's my plan is when we talk about graphical user interfaces, my plan has been to talk about something called Swing. It would be nice to have the book's reference thing, but they took Java FX out of the standard distribution in Java. And when I've tried to get it back into NetBeans, and it's so far it's been problematic. So I don't know what to do about that. But anyway, so that's it for today. And the assignment's due today and you're making good progress with it, or okay, great. And if there are no questions or comments, then that is all we have for today.